Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we talk about direct variations and how can we tell if something varies directly. We're in the Math Common Core standard of ratios and proportions. And we're going to analyze and use proportions to solve real world problems today, especially having to do with those type of proportions that vary directly. Our guiding question that we're going to be able to answer today is how can we use a graph to tell if something varies directly? Now, what on earth does it mean for something to vary directly? That's pretty interesting. You probably haven't ever used that language before. So let's talk about it. You see it all the time in something like 16 by 9 or 4 by 3 or 21 by 9. Any idea what those numbers are? Well, these ratios are something that you see and you're probably looking at something with it right now. Think about this. This is a screen from a movie theater. A screen in a movie theater has a ratio of 21 by 9. So if it's 21 feet wide, it's going to be 9 feet tall. And that is a direct variation, where if we said, hey, it's 42 feet wide, it'd be 18 feet tall. It varies directly with each other. Whereas the mobile screens that you might see on certain devices are 4 by 3. And other monitors and things you might be looking at are 16 by 9. Those are direct variations that you might see all over the place. Okay, they have to do with a ratio. So if we think about it, looking at a computer or some sort of device's screen, we can say that it varies directly by a 4 by 3 or a 16 by 9. If my screen is 12 inches wide and has a ratio of 4 to 3, it's going to be 9 inches tall. Right here. Ratio is 4 to 3. It's 12 inches wide, 9 inches tall. 12, how do you go from 4 to 12? Times 3. How do you go from 3 to 9? Times 3. It varies directly in the length and the width. What if it was 5 3/4 inches tall? What would we do there? Well, if we had 4 over 3, we had x wide and 5 3/4 inches tall. Just like before, cross multiply and divide. Nothing different there. And that can tell you that it's 7.67 inches wide. All right. Well, if we graph the data, if we look at it and we find those points on a particular graph, we'll notice a pattern. The data is going to vary directly. Therefore, we can say it is called a direct variation. Well, it'll be a direct variation if we can write a relationship between two numbers such that y equals some number times x. K is that some number, and it can't be 0. So the equation for that line is going to be y equals some number times x. And when we draw it on the graph, it'll look like a line just like this. A straight line also like this, and it must go through 0, 0. It has to go through the origin. Remember that guy right there in the middle? Right? It must be written as y equals some number k times x. So once we plug those numbers in, we will notice that it forms a direct variation. It has to go through 0, 0, whereas something like that, we're good to go, like that. Okay, y equals some number times x is our equation. Now this one, notice if we put a graph behind it, it doesn't go through 0, 0. It is not a direct variation. Now is it a straight line? Yeah, it is. It's slanted, just like some of these other guys are slanted, but it's not a direct variation because it doesn't go through 0, 0. That's the easiest test. Here's another one, like a curve or something like that. These are all not direct variations. Okay, well, let's look at these charts and see if these measurements vary directly. Let's look at this one. X is 0, y is 0, x is 1, y is 30, 2 and 60, 3 and 90. Does this vary directly? Well, remember our rules? It has to go through 0, 0, and this one does. It goes through 0, 0. That's the easiest test, one of the easiest tests you can do. Now, remember, it's got to be y equals some number times x. So if I take y, can I multiply it by some number and get, or excuse me, I take x and I multiply it by some number and get y. Well, what do I multiply 1 by here? I multiply it by 30. Okay, well, let's try it and see if that works for the other guys. If I take my x, plug it in there, is 2 times 30 what I get for y? Yeah, it is. 2 times 30 is 60. Same thing here. If I put 3 in for x, instead of writing 3, or x, we'll write 3. So it's 30 times 3. 3 times 3, 30, is 90. That's it. So this is a direct variation. It's y equals some number, 30, times x, and it goes through 0, 0. Let's do this one. Remember, it's got to be y equals some number times x. Well, what do I take if, let's just say, height is x and weight is y? What do I multiply 60 by to get to 100? Well, that's not so easy, is it? Well, let's do this. There's another trick. Remember, if we can't find out how do you go from x to y, remember it has to go through 0, 0, right? If you think about it and you go backwards, we're going down in 10 every time, right? Minus 10. Here, we're going down 20. So if I continue to go down all the way, there's 10, 10, 10, 10, 10, 10 more. That puts me at 0 because I've subtracted 10 and 10. I did that 6 times. Well, if I do this 6 times, notice that 6 and 20 gives me not 0, right? Go down once, that's 80, 60, 40, 20, and 0 there. It does not match up with 0 there. So we're going to end up having something like negative 20. 0 and negative 20 is my point. It doesn't go through x equals 0 and y equals negative 20. It's not 0, 0. Okay? So this one, the easier test is to figure out, does it go through 0, 0 or not? What about this guy? Which test is easier to find out? How do you go from, what do you multiply x by to get y, or does it go through 0, 0? Well, there's a couple different things. How do you go from x to y to get to 7? So 1 times 7 is 7. Is 2 times 7 13? No, it's not. Notice it doesn't also go through 0, 0. So those are a couple easy things you can do to test it. All right. What about these equations? Are these direct variations? Remember, it's got to look like y equals some number times x. Does this look like that? No, it doesn't, does it? If I plug in 0 for y, what spits out? 0, 2, spits out 2, 0. So it doesn't go through 0, 0, right? Let's look at this one. 3y equals x. Now this one doesn't look like y equals k times x, but we can make it look like that. If we take this and divide by 3, we get y equals 1/3 x, right? Well, y equals some number times x. We're good to go. Same thing with this one. Y divided by x equals 4. Well, that doesn't look like my original direct variation equation. I'm dividing by x, so how do I get rid of dividing by x? Well, just cross multiply here. Those go away. Y equals 4x, and bam, this is also a direct variation. What about this guy? Y equals negative half x. Y equals some number times x. Bam, this one is also a direct variation. If you're having trouble, always make a table and plug in a few values for x and see what you get for y. All right. Do these examples vary directly? We've got this guy right here. This is your x, this is your y, this is your x, this is your y, x, y, x, y. If I take x, what do I multiply it by to get to negative 4? Well, hopefully you said 4. Do I take x here and multiply by 4 and get this answer? Or do I take 1 and multiply by 4 and get that answer? No, it's not consistent, is it? And notice it doesn't even go through 0, 0. Look at this guy. Does this go through 0, 0? Plug in 0 there, plug in 0 for x. Negative 2 equals negative 2. So that one's good. So you're onto the right track there. Check and see if it varies directly though. All right. You should have got that the second one actually was a direct variation, because if you think about it, you subtract 2 from this side and subtract 2 from that side, it's still the same equation as y equals 3x, right? So again, y equals some number times x, and you're good to go. All right, write an equation where x and y vary directly with this point. Check your work to make sure that it actually works. Remember, it's y equals some number times x. So if we write that, it's y equals some number times x. Well, if I take the 2, how do I go from 2 to y? X to y. What do I multiply by? 2 times 3 gives me y. Well, that's the vector you put right in there. Same thing with this one. How do you go from x to y here? Multiply by -4. Well, that's the number you put in front of x. And that's it, huh? Not too difficult with those guys. You just got to know how to read it. All right. Well, how you doing? You able to answer our guiding question of how do things vary directly? All right. Well, that's pretty much it for today. So we talked about movie theater screens and how things vary directly. This was Matt with mathsmath.com. Check us out on Facebook at Solving Maths Problems or on Twitter at mathsmath. And enjoy math and cheesy math jokes.